Okay, so we're going to look at a few more examples. Here we have, first we have this matrix. If we circle our pivots, we've got two pivots, one in the coefficient matrix, so left of the augment, and one in the augment. Notice that we have two free variables, so those correspond to columns where we don't have pivots. Okay, and if we try and write down a solution, let's say that we have, let's call our unknowns A, B, and C. What we get is that B plus 2C is 0, and then 0A plus 0B plus 0C, which is just 0, is equal to 1. All right, this line, which corresponds to having all zeros to the left of the augment and something non-zero to the right, means that our system is going to be inconsistent, so it has no solutions. Okay, and this is based on what our augment is. Let's take a look at the same coefficient matrix with a different augment. Okay, so if you look left of the augment, we see that we have the same setup. Here we've got one pivot variable in the coefficient matrix, and we have that's it, just that one pivot in the coefficient matrix, no pivots in the augment this time. If we look at our free variables, our variables are A, B, and C. B is a pivot variable or a basic variable, and A and C here are going to be free variables. So again, we have two free variables, A and C. And now when we try and write down a solution, what do we see? We have B plus 2C is equal to 3. And then our second row becomes just 0 equals 0, which is always true. It doesn't take anything to satisfy this. Okay. So if we want to write down our solutions, this time our system is consistent. And if we want to write down our solution set, we have A, B, and C. Remember that our pivot variable can always be expressed in terms of the free variables. So B here is equal to 3 minus 2C. A has no restrictions on it, and C is a free variable as well, so it will also just appear as itself. So here we see that our solution looks like A 3 minus 2C, C, where A and C can be anything. So notice that for this coefficient matrix, because we had this row of all zeros in the coefficient matrix, in the reduced row echelon form in the coefficient matrix, notice that with some augments, we had an inconsistent system, and with some augments, we had we had a consistent system. Okay. So in the case that we see a row of all zeros, then it's possible to be consistent or inconsistent based on the augment. The next example we're going to look at is very closely related. Here, if we look at our pivots, we've got a pivot in the first row and a pivot in the second row, this time left of the augment. So this has two pivots in the coefficient matrix. We look at how many free variables we have. Notice we've got one free variable, so there's a column that doesn't contain a pivot. In this case, our free variable is A. And now let's write down the system that corresponds to this matrix. We can read this off. We have that 1b equals 3 and that 1c equals 0. Okay. Notice this is different from the case above, where all of our coefficients were equal to 0. Here, our coefficient of the c term is equal to 1. And so this is just saying we better set the value of c to be equal to 0. Okay, so here our system is consistent. And we're actually going to have infinitely many solutions. For our unknowns a, b, and c, we find that a can be anything because it's free, that b is equal to 3, and that c is equal to 0. And it doesn't matter what our augment was. No matter what our augment was, it would just give us values for what b is equal to and what c is equal to. So this is always going to be a consistent system.